Okay, now let's get into radiation resistance and antenna input impedance. Alright, so with radiation resistance, it is a feed point resistance that it is caused by the radiation of electromagnetic from the antenna itself, as opposed to the loss of resistance or ohmic resistance. Uh, Loss of resistance and ohmic resistance is usually the thing that any machine experience where there are a heat loss. Okay, the energy is used toward creation of heat. So this is one of the things that makes the machine more not more, it is less efficient. Okay, so not all power supplied to antenna is radiated, because some of them are lost due to ohmic resistance or loss resistance, and it is converted into heat. Okay, so radiation resistance and AC antenna resistance is equal to the ratio of the power radiated by the antenna to the square of the current at its feed point, where the RR radiation resistance in ohm is equal to the power radiated by the antenna is divided by the current at the antenna squared. Okay, so the radiation resistance is determined by the geometry of the antenna, where the loss resistance is primarily determined by the materials. This is the keyword. The radiation resistance is determined by the material where the antenna is made, while the energy lost by the ohmic resistance is converted into heat, like we've mentioned just now. The energy lost by the radiation resistance is converted to electromagnetic radiation, and it is caused by radiation reaction of the conduction electrons on the antenna itself. So when electrons are accelerated, it is occurred when an AC electrical field is impressed onto the antenna, and they will radiate electromagnetic wave, and this wave carry energy taken from the electrons itself. The loss of the energy of the electrons appears as an effective resistance to the movement of the electrons, and analog to the ohmic resistance caused by the scattering of the electrons in the crystal lattice of the metallic conductor. So this effective resistance is called the radiation resistance. And the other parts of this is the antenna input impedance. The radiation from the antenna is a result where the flow of the radio frequency current, and it is flown to the antenna through transmission line, the cable itself, which is connected to the small gap between the conductors that make up the antenna. So this antenna is used to transmit where the transmission line is connected is called the antenna input terminal or the feed point. The feed point presents an AC load to the transmission line called the antenna input impedance. So if the transmitter output impedance and the antenna input impedance are equal to the characteristic impedance of the transmission line, the transfer is max powered to the antenna and it is radiated. So what is radiation and what is input impedance actually? So for radiation resistance of an antenna is defined as the equivalent resistance that would dissipate the same amount of power as it is radiated by the antenna. Or in simple words, it is fictitious or imaginary resistance when the substitute in series with antenna will consume the same power as is actually radiated, while the input impedance of the antenna is related to the voltage and current at the input at the behind side. Okay, the real part of the antenna impedance represents the power that is either radiated away or absorbed within the antenna. So the imaginary part of the impedance represents the power that is stored in the near fields of antenna. So in layman's term, that radiation resistance is, so imagine that your antenna is a speaker. Okay, imagine it is a speaker playing music. So radiation resistance is like the part of the speaker that is actually turning the electrical energy from the music just now into a sound wave that you can hear. So the better the part works in the antenna itself, the louder and clearer the music, or in our case, the antenna, the signal is much more clearer and louder, right? So what about input impedance? So input impedance is like the overall setup of the speaker, including the wire, the connection, and the speaker itself. So this is what the music player, like the radio or the amplifier, sees when trying to send the music through the speaker. For the music to play, it is best. Everything needs to be in balance. No part should be too heavy. No part should be too light. If the wires of the connections are not balanced, some of the music or signal in our case just now might get reflected back, leading to a weaker and more distorted sound with a lot of noise. So radiant resistance is the part of the antenna that is responsible for sending out the signal effectively into the air, while the input impedance is the total load of your radio of your transmitter has to work with when sending signals to the antenna. If the input impedance is well balanced or well matched to your transmitter, more of the signals goes out cleanly. If not, you get a bad connection and some of the signal gets wasted. So for this, your antenna needs to work well. You want a good radiation resistance to send out the strong signal and well matched input impedance so that the signal to the antenna without being lost.